Hello students, welcome to the class of Software Engineering. Let us discuss about user testing in today's session. User testing is also called as customer testing. So it is the type of testing where the users, or I can tell the customers, they will provide the input data and advise on system testing. Means here the users or the customers will give the test data, input test data. They will provide the input test data and we need to run the system based on the given test data values, and you have to test your system. So there are three types of user testing. First one is alpha testing. So what do you mean by alpha testing? Here the users and developers work together to test a system as it is being developed. So you know that developers develop the system, correct? Yeah. So once the system is being developed, next is you have to test the system. So here what happens in this situation is the developers as well as the users are nothing but customers, because it is the customer who has put forward this contract. So they are expecting a system of such a kind that which meets their requirements. So they need to first test their system. They want to see whether their system will work exactly how they require. So both developers and users will sit together and they will start testing the system. So what is the advantage here is, even the users will be able to identify any problems or issues that which the development team may not have recognized during the development stage. So some issues they can identify. Second one is beta testing. So first one we had alpha testing. Second one is beta testing. So what do you mean by beta testing? Now here what happens is a release of the software is made available to the users, okay, to allow them to experiment and to raise problems that they discover with the system developer. So here a release of that system, so it can be a product, isn't it? So that has been given to the users. So they will start using the system. So they might identify some problems which the development team might not have recognized. So thing is, in alpha testing, your product is not put into the market. This is before delivering it into the market. The testing is done here in alpha testing, but in beta testing actually you are putting a release of that software to the market. So people start using it. So now they can give their feedback, isn't it? Yeah. Okay. Third one, acceptance testing. Now, where customers test a system to decide whether or not it is ready to be accepted from the system developers and deployed in the customer's environment. Now, acceptance testing is fully linked to your customer. So, customer will get the system from the developers. It is they who will decide whether the system has to be accepted or not. So you can, if it is accepted, they can move forward. They can put into the market. Okay. So we'll study in detail about the acceptance testing process. Acceptance testing process. So we have the figure here. This figure represents the acceptance testing process. So see here, just these are actually inputs I have told even in your general model of the testing process. I have showed that these are also the inputs. Okay. Now see here, define acceptance criteria. Thing is, your system should be accepted. So based on what conditions or what criteria the system has been accepted. Accepted means it has been decided to put into the market for release. So that acceptance criteria they must define. It's not the requirements. What is the acceptance criteria? See, you think that you have some 5 points, okay, and if 5 points in the criteria, acceptance criteria, if your product passes that all the 5 points, then you can decide that you can put it into the market like that. So first you have to define the acceptance criteria, and then that test criteria is given as input. Then you have to plan the acceptance testing. So based on that test criteria, you plan for acceptance testing. So now you have to design a test plan. Derive acceptance test. So you have to design a test plan. And then you have to derive the acceptance test. Okay, and then put all that test, collect all those tests. Using that test, you can run that test. You have the test with you, so start running the test and you get the test results. Negotiate test results means you can come to some point to agree. Okay, it's like compromising. Near to some value if you get, you can negotiate the test results, and then testing report is generated. So based on that report, you can decide whether to accept the system or reject the system. So based on that testing report, they are going to decide whether the system has to be accepted or rejected. So we'll go through each point now here. Define acceptance criteria. This should take place early in the process. So acceptance criteria should be part of system contract. So when you are signing the contract only, as well as you are specifying the requirements, at the same time you have to put the acceptance criteria also. You need to put the acceptance criteria. So acceptance criteria should be part of system contract and be agreed between the customer and developer. So better acceptance criteria needs to be provided at the beginning, that is during the agreement only. Okay, so that both developer and customer can look into that, and that means they have agreed for that. It might be difficult to define the criteria early. I agree that it's difficult to define the criteria early because you are not knowing about the detailed requirements or complete requirements, whether it is available or not. Next, plan acceptance testing. Now we have to plan for acceptance testing at 2. So for that, it's not just going and testing the system. You have to decide, do some work here. What you have to do is, you have to decide the resources, time, because how many resources are required for performing that testing process, then time also, time taken to test the product, and the budget, because again there is testing cost also. So budget for acceptance testing. Establish a testing schedule. So this schedule will give all the details when that test has to be conducted. The testing process should cover all the requirements. So whatever requirements have been specified in the beginning in the SRS, better to cover up all the requirements in the testing process. So you can show that you can test your system and come to a point that it satisfies all those requirements. And also you should also define risk to the testing process such as system crashes, inadequate performance. That is like, suppose you give a value which makes your system to crash. Okay, that range of value if you give. So try to define such risk. Next one, derive acceptance test. Once acceptance criteria have been established, tests have to be designed to check whether or not the system is acceptable. So you have defined the acceptance criteria. You have defined the acceptance criteria. Now you have to design the test in order to. So once the acceptance criteria has been established, you have to design the test in order to check whether or not the system is acceptable. Acceptance test should aim to test both functional and non-functional requirements. So you have to design the test in such a way that it should test both functional as well as non-functional requirements. That means it should satisfy all the requirements which you are specifying in the SRS. Fourth point, run acceptance test. So next is you have to run the test. So acceptance tests are executed on the system. So they should take place in the actual environment where you're going to use the system. So that's why it's called acceptance testing. So you have to test where are you going to test the system, in the real environment where you are going to use the system. Then negotiate test results. It is very unlikely that all of the defined acceptance tests will pass. So all the tests will pass. We cannot give 100% assurity. There will be some problems in the system. If this is the case, then acceptance testing is complete and the system can be handed over. So if there is no issue at all, then that means your system has successfully passed all the acceptance tests and you can deliver it. If there are some problems, then you have to see whether the problems are minor or major. So if it's minor, somewhere you can negotiate, you can compromise. Both the customer and the developer can compromise to decide whether the system can be still put into use. So they must agree on the developer's response to identify problems. The last step is reject or accept the system. So this is a stage where both the developer and customer should sit together. They have to conduct a meeting and decide whether or not the system should be accepted and put into the market. If not good enough for use, then fix the problems. Fix the problems means if there are some issues and you think that you can resolve those issues, then you resolve it. Once complete, acceptance testing is repeated. So if there are some minor issues, light issues, and you can still repair it, means do it, and then again you have to run the acceptance testing once again. Okay, rerun the acceptance testing. Let us now discuss about software evolution. So I told that software development does not stop when a system is delivered, but continues throughout the lifetime of the system. So software development process doesn't stop once you have developed the software and delivered it. I've told in the beginning. So it's a continuous process. So once the system is deployed, it has to change to remain useful. So if you want to use your system for a long period, then you have to keep on changing your system. About two-thirds of software cost are evolution cost. about 2/3 of software cost are evolution cost. Imagine. Software evolution is triggered by changing business requirements and also by reports of software defects. Now, why there is a software evolution? Because you know that the business is high. There is lot of demand from the business side. So business requirements keep on changing. So as you know, the technologies also change day by day. So because of the changing requirements of the business, this software evolution is done. And also, even if there are some errors, defects in the system, so we are moving to the software evolution. Software engineering process is viewed as a spiral process. Entire software engineering we can view as a spiral process. The spiral process begins with requirements. You know that initial one, requirements. Okay. Software engineering process is viewed as a spiral process. So the spiral process begins with requirements. First you begin with requirements, then is the design, then is the implementation, and last is the testing, which goes on throughout the lifetime of the system. You start by creating release 1 of the system. Release 1. Like suppose you think iPhone version, first version was released, then again next version. So why there was release? Because it is because of the demand of the people. So they wanted some new features. So iPhone people started implementing it. Correct? So how many versions you have? There are several versions released by the iPhone. So that is called here release 1. So once delivered, changes are proposed and the development of release 2 is started immediately. So once they get all those proposals, change proposals, you will start implementing that change and you get the release 2. So you can see here the spiral model of development and evolution process. So here it starts. What is the first one? Specification, means your requirement specification. So first you will begin in your software evolution process also. You begin with the requirement specification. That is nothing but the new requirement now. Then next implementation, then validation and put into operation. So that is release 1. Next again, next spiral. It begins with specification. So there will be some change proposals. You are trying to implement it, validate it, put into operation. You get release 2. Next, release 3. Like that. It goes on. So I said that it continues throughout the lifetime of the system. Now we'll see the difference between evolution and servicing. What is the difference between evolution and servicing? Evolution means you are making changes to the software architecture and functionality. That is evolution. You are making completely the changes to the software architecture and functionality. Whereas servicing means here whatever changes you do are very small, relatively small, but they are essential changes. Like you are servicing your car. Okay, so they are making changes, but those changes are not a very important changes like what you do in evolution. So you can see here evolution and servicing. Initial development you have and you are doing evolution, and here servicing, phase out. Now we'll see about the evolution processes. Evolution processes depend on the type of software being maintained. So whatever evolution processes you have, that mainly depend on the type of software which you're going to maintain, and also depends on the development processes used in an organization, and also depends on the skills of the people involved in it. So keep in mind that evolution processes mainly depend on all these. Depend on the software which you're going to maintain it, depend on the development processes used there, depend on the skills of the change. Proposals are the driver for the system evolution in all organizations. So, which is the main driver here? Change proposals. So, what are these change proposals? Which the proposals which you have put forward for making any changes to your system. So, you can look at the diagram now. You can see here we have change identification process first, then change proposals, then software evolution process, and then new system. So change here first we have change identification process. What do you mean by that? See, this is a process first where you need to identify the changes, what changes you have to make. So you have to first identify what are changes or modifications you can do to the system to satisfy the user. So here then we have the change proposals. Now we have made the proposals for changes. We have listed all. So change proposals may come from either existing requirements which has not been implemented. That is, you have that requirement already with you in the SRS, but it has not been implemented. So one of those can be included in your change proposal. So that can be there. Another one, request for new requirements. So your change proposals can contain new requirements implementation. And third one is bug reports from system stakeholders. So stakeholders are who are using the system. So they will give the feedback that what can be done more to improve the quality or the performance of the system, or if any kind of bug is there still, they can report it. So from that you can derive your change proposals. Fourth one, new ideas for software improvement by development team. So these change proposals are given by the development team itself. So they will put forward some new ideas so that they can improve the software, so which is done by the development team. The processes of change identification and system evolution are cyclic, that you can see in the diagram, and continue throughout the lifetime of the system. So it continues throughout the lifetime of the system. So here change identification process, you're identifying what changes needs to be made, then you are put forwarding the change proposals, then that to the software evolution process. So it is the main driver. This change proposal is the main driver for your system evolution process. And finally you will implement it and you will get a new system. Next we'll see the software evolution process, or it's also called as system evolution process. So here first you are putting forward the change request. So you are requesting for certain changes to be implemented in the system. Next, impact analysis. What do you mean by impact analysis? You are analyzing what might be the impact on your system after implementing such changes. So we have the major activities involved in software evolution are shown in the figure. There one is change analysis, release planning, system implementation, releasing a system to customers. So we have change analysis, impact analysis, release planning, this is another activity, change implementation, and system release. So these are the major activities in this software evolution process. So we will see one by one, okay? So first, I've told that you have the change request. First, request to implement some changes in your system, and then you have impact analysis. So what is impact analysis? Is you are analyzing what might be the impact on your system after you implement the change. So it can be either cost, or it can be the performance you're going to see, or you can see what all parts of your system are being affected by implementing that change. So these all can be your impact analysis. If the proposed changes are accepted, a new release of the system is planned. Can you see here? Release planning. What do you mean by release planning? What do you mean by release planning? See, if the proposed changes are accepted, then you can decide for the release of the system. Okay. During release planning, all proposed changes. So here you are analyzing whether what might be the impact of these changes on the system. So you will decide, you will come to a decision whether to accept it. So if you are accepting it, then you can plan for the release of that system. Now in release planning, you can see you have fault repair, platform adaptation, system enhancement. Platform adaptation is your OS. So during release planning, all proposed changes, that is fault repair, adaptation and new functionality, all these are considered. So if any, in release planning, we are considering if there are any faults, you're going to repair those faults. Platform adaptation, you're going to see whether you can make your system adaptable to the platform. System enhancement, that is, enhancement means you can add new functionality. A decision is then made on which changes to implement in the next version of the system. So now we are coming to a decision, system release, no? So change implementation, you are implementing all those changes, and then system release. So there you are going to decide, okay, which changes to implement in the next version of the system. The changes are implemented, you have to implement the changes and then validate it, and you have to, a new version of the system is released. Understood? The process then iterates with a new set of changes proposed for the next release. So here, change implementation. So you are implementing all those changes, and then you are deciding to release the system. At the same time, you are also going to see that what changes can be done for during the next release. So again, next release is continued as per those changes which you have decided to be implemented during the next release. That change request you are considering. So the process then iterates with a new set of changes. This will be new set of change proposal, okay, for the next release. Now, next topic, program evolution dynamics. It is program evolution dynamics. So what does this term indicate? Program evolution dynamics. It is the study of system change. So I told that we can change our system, we can modify it, update it. So program evolution dynamics is nothing but the study of system change. So we are going to study about that. So majority of work in this area is carried out by Lehman and Bellardi, these two persons, and Lehman proposed laws concerning system change. So regarding this system change, Lehman has proposed certain laws, and these laws are called as Lehman's laws. Lehman's laws. So we will see one by one. First law is continuing change. By this term only you can get to know change. You want to do changes to the system, but that is continuing. So changes never stop. It is always continuous. So why it is continuous? You know that Once the system environment changes, there will be new requirements. New requirements emerge. You need to modify the system. So once you modify the system and you get a final system that you will put into the environment, then again that will promote more changes to the environment. Clear? So as your system environment changes, new requirements emerge. Okay, so you need to modify your system to adapt to those requirements, and then you build a new system. Now this new system you will put into the actual environment to use it. So this will promote more changes to the environment. Second one, increasing complexity. Now you are changing the program. Keep on changing the program means the structure of your program becomes more complex. So that's why what happens once your system is very complex, it will be very difficult to understand your system. So you have to spend some time in improving the structure of your system. You want to implement the change, it is true, but you try to see that your system structure doesn't degrade. So you have to improve without adding to its functionality. Third law, large program evolution. Large program evolution means suppose your system is very large and complex. Then what happens? It's very difficult to understand the system. And there are chances that the programmers are more likely to make errors and introduce faults. So a small change avoids reducing the dependability of the system. Understood? A small change if you are doing, it avoids reducing the dependability of the system, reducing the dependability feature. Dependability means, the entire system is made up of subcomponents. So each component will be interlinked with other. So you are doing some changes in one component, it might affect the other components. So if it's a small change, it's not going to affect much on dependability. But if it's a large change, it will probably introduce many faults that will limit other changes. Okay, so a large change will introduce many faults. Fourth law is organizational stability. Over a program's lifetime, its rate of development is approximately constant and independent of resources devoted to system development. So that is organizational stability. So if you consider the lifetime of your program, the rate of development will remain constant. Fifth law, conservation of familiarity. Conservation of familiarity. What do you mean by that? The incremental change in each release is approximately constant. The incremental change in each release, whatever increments you develop in each release, that will be constant. Sixth law, continuing growth means again the growth is continuous, means more and more functionality should be added to maintain user satisfaction. So finally to come to a point of user satisfaction, you have to reach their target. So you have to add more and more functionality. Seventh law, declining quality. So quality of the systems will decline unless they are modified to reflect changes in their operational environment. So when the quality of the system declines, see, you need to maintain the quality of the system. So that's why you have to make changes so that it should always be working in its environment. Eighth law, feedback system. This is very important. See, anything you do, any changes you do, for your product or system, keep a feedback. So that the feedback system, if you have kept for it, then you will be able to know how much your product has achieved. What is the quality? What is the performance? So you get the reviews there. These are the lemons laws. So there are 8 layman's laws.